Gosh, we've got a lot of people here already. That's absolutely fantastic. Lots of people logged in.
70 already. Excellent. Welcome, year 8. We'll just wait until you're all here, but I don't think that will take long. You're going up very, very quickly.
Someone in the Q&A box has said, hi, Miss McGinley.
Hello. Who said hello?
Oh, and Happy New Year. Fantastic.
Hi, Lily.
Wonderful.
Happy New Year. Hi,
Happy New Year to
Grace.
all of you.
Hi, Anonymous. Hope you all had a lovely Christmas break. Just give another couple of minutes until it stops going up. Right, okay, it's stopped. So, oh, hand raise.
So if you click the raise hand button, it doesn't actually really do anything. I'm going to be answering the questions in the Q&A box as Miss goes. So I'm going to disappear in a minute. I'm going to be in the background answering your questions if you've got any. And I'm going to leave Miss to get on and explain everything else.
Okay, so let's get started. So welcome, firstly, year 8s to this is your first science webinar for your remote learning, and we are very, very excited to have you. So last year when you were year 7, you produced such brilliant work during this off-site learning period. So we're very excited to work with you over the next few weeks. Firstly, well done for all logging on so quickly and for, as always, adapting so well to all of these changes and these new ways of working. Some of you may be watching this as a recording, which is absolutely fine. We understand that everyone's schedules might be slightly different when it's at home working, but the advantage of you guys that are here now is that you can ask questions in the chat. So Mr. Lamb will be answering your questions, and we're also going to have a question and answer session at the end, so we can answer them all together. So I'm going to start sharing the webinar slides with you now. Now these are in your classroom, but you shouldn't look at them until you've really watched the webinar, because it works best if you watch the webinar while you're doing your work. So the webinar is going to be recorded so you can watch it again and again while you're going through the work. We don't expect you to memorize or learn any part of this webinar. It's just to help you. So if you're wondering where to find the webinar afterwards, I'm just going to show you now. Bear with me a moment. So if I just share my screen with you all. Okay, so please do say in the Q&A box if you're having issues seeing this, and then Mr. Lamb, you can jump in and tell me that it's not working. But here is the Varndian Science YouTube channel. It has Mr. Lamb's name because that was the only way it would work with his email address, but this is where you'll find everything. So if you go to playlists, it can look a little bit confusing at first, but if you go to playlists, you'll find a year 8 videos playlist. Now it will be all the videos from last time as well, but if you scroll through to the most recent ones, and obviously you can look at the video titles as well, so this one will be called something like Resultant Forces. Then you can find the recording of this webinar, and all the future webinars will be uploaded there too. Feel free to have a look at any of the other videos as well, obviously. Your teacher should also post this into the chat. So let's just come back together for a moment. So we're going to get started with the webinar now. So bear with me a moment. Okay, so I'm going to share my screen with you all again. Give it a moment. While it just loads. Okay, so maybe you can't see it yet, but what the first slide is saying, it's just talking about this schedule. So you all should be quite familiar by now with the timetable document you've been given. And, oh, wrong slide. And what it basically tells you is that you'll have a webinar at 2B or 2A today, whatever time slot this is. And then straight after, you'll have your slot where you will do your science work. So this means you then go to your Google Classroom and do that. However, each slot is only 45 minutes, so you shouldn't be spending more than this on science a week, even if you don't do it at these exact times. So the reason we've set these limits is because we're aware that you have lots of other subjects, and we want you to be able to structure your time effectively and not spend hours and hours and hours on your science work. We know that all of you are so enthusiastic about science and you work really hard, which is absolutely fantastic, but it's really important that we get a good balance and you get plenty of time to relax during this time as well. Any questions about any of these, you can obviously email me or your class teacher. Okay, so how do we do remote learning in science? So you can ask any questions you need to during the webinar using the chat box. You will have access to these slides when completing your work. So the teaching and explanation part will only be about 15, 20 minutes of new content. So we can see that we're however many minutes we are into the video now. You don't really need to rewatch this bit if you don't want to. And then we'll leave some time for question and answer at the end. Okay, you don't necessarily need a pen or paper for this. You will be answering questions during it, but via your computer on pause. So by the end of this webinar, you should be confident with the following things. Now, this may be revision and extension for some of you, as you should have covered this in your lessons. So we'll be covering the unit of forces and how we show forces using arrows. We'll be looking at how forces affect objects. We'll be identifying balanced and unbalanced forces and calculating resultant forces, and ultimately thinking about what do resultant forces mean for the movement of the object. There's quite a lot of overlap with GCSE topics with this topic here, especially as we get towards the end of the webinar. Okay, so let's get started. So let's start right from the beginning. What is a force? So we can't see forces, but we can see the effect of forces. Forces cause a change in speed, direction, or shape of an object, and they are measured in newtons, which we represent by showing a big N. So here are some examples of forces, or these might be kind of diagrams you might have looked at in lessons of forces. Now, if we were in a classroom, I might get you to call out some examples of some of the forces that you can see, but obviously we're not, so if you just think about them in your head for now. So we can see we have examples of gravity, magnetism, air resistance, friction. Mr. Lamb, could we have the first poll, please? So, which force is acting between the train and the tracks, causing heat? It said multiple choice, but there is only one answer. I'm not sure why it's done that. So I cannot see who has put what answer, by the way, in case you're nervous about voting. It does not tell me who has put what, only an overall percentage. Okay, so 20 seconds left. Remember, it's entirely anonymous, so just have a guess even if you're not sure. Okay, timer's still going. I'll give it another 5 seconds. So if you haven't voted yet. Okay, wonderful. So 87% of us have got the right answer. It is friction. So that was just to get us started off, just thinking about the different examples of forces that we know in real life. Excellent, well done, guys. Okay, I don't know how to get rid of that. Right, moving on. Okay, so although we can't see forces, as I said before, we can see the effects of forces, but there's a way that we show forces in scientific diagrams, and that's by using force arrows. Now, force arrows are really important because they show the size and the direction of a force. So obviously all arrows have a direction, and that's the direction the force is acting in. And the size of the arrow tells us the size of the force, so how strong that force is. Mr. Lamb, could I have the next poll, please? Okay, so on this diagram, which force is shown by the downwards arrow, so this purple one here. Is it air resistance, gravity, upthrust, or friction? Okay, another 5 seconds. 5, 4, 3, 2, 1. Okay, wonderful. So 82% of you have got the right answer. That's an absolutely fantastic start. So the answer is gravity. So quite a few of you also put air resistance. Now, while air resistance is involved in this diagram, it's not the force shown by the downwards arrow, because we know that gravity is the force that pulls objects towards the centre of the earth, so it's always pulling them down. So we know that's the direction that gravity works in. Really well done, guys. I don't know how to get rid of this. Right. So this is how force arrows can be used. Oh. Okay, so we're going to think a bit about force arrows in terms of balanced and unbalanced forces. So force arrows normally come in pairs. So a pair of force arrows are ones that are working in opposite directions to each other. So they're working against each other. Now, here is an example of where the force arrows are balanced. So we say that they're balanced because it might be difficult to see, but they are actually exactly the same size, the arrows, and I know this because I copied and pasted them. So they are identical. So if the two force arrows are the same size, it means that the forces acting in opposite directions are exactly equal. So the effect this would have on the car, I'm going to give you about 10 seconds to have a think about that to yourself. So what effect would this have on the movement on the car? How do you think this car would be moving? Now, unfortunately, I can't get a show of hands for this, but hopefully you've all had a chance to think about it. So if the car is already stationary, it will stay. Oh, I can see some of you raising your hand. That's brilliant. Unfortunately, I can't do much with that, but it's great to see that a lot of you have been thinking about it. So if the car is already stationary, what this means is that there is going to be, it's going to stay stationary, because there is no force that is going to be accelerating, overall force that's going to be accelerating in either direction. If the car is moving, however, it means that it will stay moving at a constant speed. Now, it's a really common misconception that if forces are balanced on an object, that it's always stationary, which means staying still. But actually, it also can mean that it's moving at a constant speed. So if this is something that you thought it had to be staying still, then make sure you're really clear on that. We will be going over that again later in the webinar, and making that really clear. Okay, going on to the next slide, so we can see that the arrows have changed slightly. Mr. Lamb, could I have the next poll, please? I think this is poll 3. Okay, so this car now, in this diagram, are the forces acting on it balanced or unbalanced? So I'm trying to move out of the way so we can see it. I don't know if that's helping or not. Just going to keep it there. Okay, 5, 4, 3, 2, and 1. Okay, so 71% of you have said that it's unbalanced, and that is the correct answer. Well done. So we can see that the arrows are unbalanced because the arrows acting in opposite directions are not the same size as each other. So we say in this case that the forces are unbalanced. Okay, moving on to the next slide. So we can see here we kind of have like a reverse of the arrows here. So still unbalanced, but we can see that the forces are the opposite way around. So in this case, the force that is the backwards facing force is larger than the forwards facing force in this case. So again, what does this mean for the movement of the vehicle? Okay, so we're going to give these forces some names. So the forward force is typically the thrust from the engine, and the backwards facing force would be frictional forces such as friction or air resistance, but we're just going to stick with friction for now to keep it simple. So what this means is that the thrust force from the engine accelerating the car forward is bigger than the friction that's causing the car to slow down. So the car will be accelerating in a forwards direction. So if the car is already moving in a forward direction, this will mean it's going to speed up. So that's an example of how forces can change the speed of the car. Now, this one is slightly more complicated. An easy misconception is to automatically think that the car is moving backwards, but this may not necessarily be the case. So what this means here is that the frictional forces, so this could be caused by slamming on the brakes, for example, are larger than the thrust from the engine driving the car forward. However, if the car is already moving, this doesn't necessarily mean it's suddenly going to start moving forward, doesn't necessarily mean it's suddenly going to start going backwards. What it will do is instead cause a change in speed. So it will cause the car to decelerate, we use. So that's the word that means the opposite of accelerating forward. So we say it will cause the car to slow down or decelerate. Okay, so here are some clear rules for balanced forces. So when the forces are unbalanced, the object is either changing speed, shape, or direction. And that depends on a few things. It depends what the object is already doing, and it depends which force direction has the larger force, and also resultant forces come into that, which we're going to come on to in a second. When the forces are balanced, the object is either stationary, so that means staying still, or travelling at a constant speed. Okay, now we are going to come to adding some numbers onto our force arrows and doing some calculations. Mr. Lamb, before we go on, do we have any questions so far?
No, at the moment, I think I'm fine with answering everything in the typing. One of the things that people have asked me is what they're actually meant to do. And I know that just for everyone, Miss is going to get onto that as we get towards the end.
Yes, thanks for bringing that up. So yes, at the end of the webinar, so as I've said, you don't necessarily need a pen or paper for this webinar. You just need to be watching and answering the polls that come up. At the end of the webinar, I'll tell you exactly what your task is to do next. Thanks for that, Mr. Lamb. Okay, so as we said, force arrows show the size and direction of the force, but there's actually a way of quantifying this. So quantifying just means to give something a number. So rather than just looking and seeing which force arrow is bigger, the forces actually have a number for their size. So we can see that we're going back to our leaf diagram again, so our leaf that's falling. So we can see that the force of gravity, so this downward facing purple arrow, is the value for that force is 50 newtons. So remembering that newtons is shown with this large N. And the force that's working against this would be air resistance. And that is, the value for that is 15 newtons. Now, what we can do is we can calculate something called a resultant force. Now, the resultant force is the overall force that is acting on this leaf. And with resultant forces, you take opposite forces away from each other. We never get a bigger number, we never get a negative number, but we just then indicate the direction of that. So we'll do an example together, and then hopefully that'll become a bit clearer. So Mr. Lamb, could I have the next poll, please?
And I miss, I can't remember if we're on number 4 or 5.
Let's try 4 and see what it is. Oh no, that was meant to say leaf. No, we'll skip that one. We'll go into the 5th one. Oh, we're answering it anyway. Unbalanced, good. Well done. You understood that lead meant leaf, and you knew it was unbalanced. Good work, guys. Okay, so we're now going to calculate the resultant force on the leaf. So you've been given the two values. So what you need to do is take them away from each other and also indicate the direction. So I'll give you a bit of time to do that. So you can obviously do it in your head, but you may need a calculator at hand. And I would recommend, especially if you're in assessment, using a calculator where you can, because it just prevents you making those little mistakes. It can easily be done in the head. So if you can use a calculator, you may as well. Okay, 5 more seconds. 4, 3, 2, and 1. Wonderful. So 73% of you have got that answer correct, which is absolutely fantastic. The answer is 35 newtons down. Really well done. So we work that out by, we take away 15 from 50, so we're left with 35 newtons, and that will be in the downwards direction because that was the bigger force. Any questions about this, put them in the chat box, and we'll either, if Mr. Dan thinks they're urgent, we can stop me and I can go through it now, or Mr. Dan will answer them for you. So resultant force shows an acceleration in the direction of the arrow. This can be shown, as we've said, as a change in speed, direction, or shape. So going back again to look at our examples of the car, we can see that the overall resultant force here would be, although there aren't any numbers, we can see it would be in the backwards direction. So that would either cause a change in speed, so it would cause the car to slow down, or if the car was started stationary, it would cause the car to change direction and will start in the backwards direction. Okay, and forwards again. So remembering you will have access to all this information in the webinar slides, you don't need to write anything down. Okay, we're going to look at a slightly more tricky one at the moment. So in this diagram, they haven't even given us the force pair, the counteracting force, but doesn't always matter. I just want you to use the information that you've got in front of you. Mr. Lam, could I have poll 6, please? Okay, so the resultant force on the trolley. Now, I hope that you guys can see right in the same way that I can see right. On my screen, right is the side that's got the 2 numbers on it, and left is the other side. Okay, 5 more seconds. 5, 4, 3, 2, 1. So again, we're having a really consistent, about 70% constantly getting the answer right. That's fantastic results, guys. Really well done. So the answer is 90 newtons to the right. And so if the 2 force arrows are on the same side, you add them together to get the force for that side. So in this case, those are the only force arrows we have present. So our overall resultant force is 90 newtons to the right. Really well done. Let's take a look at a slightly more complicated example. Oh, where are we? Oh. Okay. So we can see there's more force arrows brought into play this time. Mr. Lemke, we have pulse 7. I want you guys to give it a go at calculating the resultant force on this trolley. Okay, 5 more seconds. 5, 4, 3, 2, 1. Okay, absolutely brilliant work, guys. So really high percentage getting it correct this time, 83%, and this is the most difficult question so far. So that's absolutely fantastic. So we can see that on the right side we have a total. So first we added these 2 together, get a total of 90 newtons, and then you took away the force on the other side, which was 10 newtons. So overall the resultant force would be 80 newtons to the right. So we can, this shows to us that it is accelerating in the rightwards direction. Really well done, guys. Oh, why isn't this working? So bear with me a second. Oh, there we go. Okay, so this is just another diagram, just kind of putting some words onto how to work out resultant forces and what that actually means for the movement of the object. So when the forces are unbalanced, the object is going to be accelerating in a particular direction. So accelerating, as we know, is just another way for saying speeds up. And if this was reversed and the bigger force going backwards, the truck would be decelerating in the opposite direction. Okay, and just a reminder for us that if a If the force arrows are balanced, the object is going to be either travelling at a constant speed or stationary. Now, in some of the extension work, you may see examples where there's 4 arrows around it. What I'd like you to do with this is it's exactly the same principles as what we've been talking about. You can use exactly the same rules, but you just need to take them as pairs. So in this case, our red and blue arrow are pairs and our green and yellow arrow are pairs. So if we look at the first diagram, we can see the red and blue are balanced. And then if we look at the second one, we can see that the red and blue are unbalanced. So the car is going to be accelerating in that forward direction. And then in the last diagram, the red and blue are also unbalanced, but the car will be accelerating in the opposite direction, so decelerating. So just so it doesn't throw you if you see any of these in the extension work, you just treat them exactly the same, just take them as pairs. So the main takeaways from this webinar. So forces are measured in newtons and can be shown using force arrows. Force arrows show the size and direction of the force. If the opposite arrows, so remembering about our pairs, if we're going opposite directions to each other, are equal in size, we say that they are balanced. And we're also now familiar with the fact that sometimes you can have 2 arrows on one side and we add them together and treat them as one force. Balanced forces mean the object is stationary or travelling at a constant speed. Resultant forces can be calculated by taking opposite forces away from each other. Before we get on to the question and answer, so what you're now going to be expected to do is in your Google Classroom, your teacher will have put a Google form quiz. You are all going to do the Google form quiz, but you will do it using the webinar slides and the webinar recording. Now, the webinar recording will be uploaded as soon as possible after this webinar to Google Classroom as well, and will also be on that YouTube channel that I just showed you. You are going to work through the Google form. You're not going to guess the Google form. You're not going to try and complete it as quickly as you can, and you will not have been expected to memorize this webinar. You are going to use the information in the webinar at the same time as completing a Google form sheet. We expect you to watch this webinar multiple times, so please do that. If you finish that within the 45 minutes that you are allocated for science now after this webinar, then do go on to the extension and challenge work. So that will be a series of exam questions with annotated notes to help you, and then you can put your answers underneath. Now, the exam questions towards the end of those Google slides are GCSE level questions. Now, I know that some of you really enjoy challenging yourselves, and I really do encourage you to give them a go if you, and only if you, have enough time. And then you can hand everything in on Google Classroom. So your teacher will have set up a folder for that. So now we have time for question and answer, both about any of the content covered and also about what you're expected to do now.
Hi, Miss. So we've had a lot of questions during that. In fact, we've had 105 questions.
Wow.
During that. Now, some of them were very sensible questions. Some of them were, could I go to the toilet and my pen's run out, which I don't believe. The things that people have asked, so what's the actual work? I think Mrs. explained that now. The actual work is you have a Google quiz in the classroom. You also have some slides with some questions on, and some of them are difficult GCSE questions. Some people said, I think this is quite easy. Well, those questions aren't easy. And what you need to do is take these these principles and use them for the challenge questions. Those should all be in your Google Classroom. Miss also just said you need to watch the webinar again. So when we end in a minute, I will download this and put it on the Science YouTube channel. That takes about 15 minutes to happen. I will then send the whole of year 8 an email link to this video. The idea is that you actually watch this so that you can use it. Miss has said that a couple of times. What other one? Where would the extension questions be? They're in your Google Classroom. It's called challenge questions, I believe, Miss. That was the title of the slides. And so the Q&A is about forces. Yes, it's about anything that you find difficult about this. Just answering a few others. People said, can anyone see me? No. I can't do the work because I need to eat my lunch. Well, that's fine, as long as you do the work before the next lesson. The test questions are hard. Good, they're meant to be quite difficult. Is the webinar done? Yes, you can leave now if you haven't got any questions. There is no quiz in my Google Classroom. Please email your teacher and ask them where that quiz is. Where are the questions on the slides? If you go into the challenge questions, there should be questions in there.
Yeah, I'd just like to add, you're not expected to write anything on these webinar slides. I know last time we did this remote learning, you would often use webinar slides and fill in answers on them. You're not going to be doing that at all this time. You're just going to use them to help you. So you're going to be just answering the Google form, and then the challenge and extension slides, those are the ones you write onto the exam questions.
Sorry, I'm typing away here for a few others. It might be easier if I just read through them, Miss.
Wait, actually, I think, can I see them now? Oh yeah, I can see them.
Right, so there's no quiz on the Google Classroom. Again, that one is you have to ask your teacher. I should imagine it will appear very shortly.
Yeah, and somebody said, so the webinar's an instruction for the quiz. Yes, it's more like, yeah, so this is the information you need in order to be able to do the quiz. Anything else? I
think that looks like it's everything, Miss. So if you all just leave the room now, and then I'm sure Miss will end it in just a second, and I will get on downloading the video.
Wonderful. Okay, thank you so much for attending, guys. Brilliant to have you as always, and I will see you all next week. How do I now do this? Oh, I think I'll stop sharing first.